I'm good at drawings. Right?
No, it's test. Like it's real written AP pre-cal. Okay, so here we go. This is going to be function transformations. If you were going to write an overarching phrase here or an overarching rule that we have used over and over for transformations of functions, what would you say?
Insider's law.
Okay, I would write that down. Insiders lie. And then outsiders tell the truth. And this is not news. This is old information. This should be in your souls. Okay? And this applies to trig functions. Excuse me. So previously, we learned how to identify the midline amplitude period from the graph. Now we'll learn how those properties affect the equations. Okay? This should be no surprise to you. The midline is simply a vertical translation. So when you see at the end of this trig function, this plus d value, plus d, that's going to be helping you find the midline. It's going to move up and down with the vertical translation of that function. Everybody clear on that? Okay. Do y'all remember the day that we started looking at this stuff and Joseph said amplitude is a vertical dilation? And I was so proud of him for that. Y'all remember the one day I was really proud of Joseph? Okay, I like the word dilation here. I feel like dilation feels better than stretch or shrink because it covers both. Vertical dilation, that's going to be this letter A, the coefficient A that lands in front. Also remember that amplitude is absolute value of A. It's a number distance-wise. Distance is always positive. So if I'm measuring distance, I could be measuring distance from midline to minimum, and that's still going to be A. Everybody good with that? No questions. Okay, and then we see the period. Period is the result of a horizontal dilation, and for that we use the letter B. Period is horizontal dilation. Okay, and we're really clear about that being an insider. Horizontal dilation. So what we expect is that B number is going to kind of flip-flop with the period. All right, so knowing that, we're given this function. It says a vertical dilation by a factor of A, where A is amplitude. Sorry, y'all, I'm going to absolutely lose it. I'm trying not to. Okay. Note this. Listen. B is responsible for the period. We see that that's a horizontal dilation by a factor of 1 over B. So if you're ever looking to see what is the period of this new function, you take 2 pi and divide by B, the coefficient of theta. 2 pi divided by B. Okay, so let's dive into example 1 here. We're given this graph. We know that I always start at the midline because that's the most obvious thing to read from the graph, right? Midline is at y equals 3. So in this problem, D is 3. Thank you. D is 3. Amplitude is 6. What does that tell me?
That it's 6.
What letter? A. A equals 6. Okay. Period is pi. Well, period is found by doing 2 pi over B. And the period in this problem is pi. You see where we're headed with this? How do we solve for B? I've got an equation that says 2 pi over B is equal to pi. Multiply both sides by B. So 2 pi equals B pi. Divide by pi. B must be 2. That's where we come up with that number. Got to solve for B. And here they're not telling us anything about it being a phase shift. No C, no horizontal translation. So if we're going to write this equation and we've got letters A, B, and D, our equation is going to be h of theta equals, what's A? 6 sine of B theta, so 2 theta plus D, which is 3. Good? All right, let's go on. Example 2 is at the top of the next page. It says the figure shows the graph of a trig function f. Write the expression for f of theta. What's up? How would you know if it's sine or cosine? Okay, that's a great question. Typically, I look at the y-axis. If I can tell that it's starting with a hump, cosine. If I can tell that it's starting to rise, sine. Because I know sine goes through the origin and cosine goes through 0, 1. So if I can tell I'm starting at an up place, typically that's cosine for me. If I can tell I'm starting in the middle on its way up, that's sine. Now, that's not to say that it hasn't been translated, right? Because they're both sinusoids. So it kind of just comes with intuition and context of that particular problem. A really good guess, yeah. For me, I would say this one does not begin on the y-axis with an extreme. So probably I'm dealing with sine. Okay. What's the midline here? Okay, y equals 3. So D is 3. Amplitude, distance from midline to maximum, or distance from midline to minimum, 3. Okay, what's the period here? Is it 2 pi? Okay, I can measure from crest to crest. I can measure from trough to trough. I could measure from starting point to starting point, which seems to be 0 to pi. You agree? So the period here is pi. Period is found by doing 2 pi over b. We need to solve for b. So feels like it's 2 again. You could multiply by b, divide by pi. B equals 2. Okay, so our function here, f of theta, is going to be 3 sine of 2 theta plus 3. Yeah? Everybody okay so far? Okay, here comes example 3. It says this figure shows the sinusoidal function g. What are the values of the period and the amplitude? Period. Start to finish. What you got? Pi. I think the period is pi, so I'm already done with C and D. Amplitude, distance from midline to extreme. 2. Don't think that amplitude is top to bottom, crest to trough. It's half the distance from crest to trough. Okay? Midline to max. Cool. Example 4. Trigonometric function has a maximum at the point pi over 2 comma 6. After this maximum, the next minimum occurs at pi comma negative 4. Which of the following could be an expression for f of x? Okay, so really going to go to work here. The first thing I can tell when I start looking at this, if I've got a maximum at pi over 2 comma 6, and then the next minimum occurs at pi comma negative 4. This is at pi over 2. This one's at pi. I'm going to have to come back up to 3 pi over 2 to hit my next max, which tells me that the period is how much? Pi. Yes. So 3 pi over 2 minus 1 pi over 2. That measures the distance from max to max. Y'all following that? Is equal to 2 pi over 2, also known as pi. Now, if the period, that does not find me b. This finds the period, right? Period is 2 pi over b. In this case is pi, so what is b? Are y'all seeing how that's evolving? Okay, so b is 2. I can eliminate a and c. A and c. Okay, next. Maximum happens at 6. Minimum happens at -4. So you can take the distance between 6 minus -4, that's 10. Does that give me amplitude? That's the distance from maximum to minimum. No. I got to split the difference. So amplitude is 5. Amplitude is 5. Now, if I add 5 to -4, add 5 to my -4, or subtract 5 from my 6, where does that put my midline? 1. D is 1. Can you work it? Lots of information there. Lots of application. All you get is 2 points. You got to know from max to min is a half cycle, right? All right, let's go on to example 5. This one's interesting because you're given a trig function, 3 times sine of 2x minus 1. Which of the following could be this graph? So what do you think first?
Not A.
It's not A. How do you know, Joseph?
Because the midline is 1.
Okay, so you're looking at the midline first. That's what I do too. That's the most obvious to my eye. If I can see that D is -1, then that means my midline should be -1. He says it's not A. Do all of the rest of them have a midline at -1? Feels like. Okay, so what's next? What's your next check? Period? Okay. Or amplitude. I would check amplitude first, just naturally to me. But they all do have an amplitude of 3. They all have the same height. Everybody here has distance from midline to max is 3. Okay, so that's over. Okay, so now we're looking at period. It should complete a whole cycle in how much? Pi. Now here's how we know. B equals 2. Period is 2 pi divided by B. 2 pi divided by 2 is, they should complete a cycle in pi. Okay, so look at number 1. It completes a whole cycle in 2 pi. That's letter B, sorry. No good. Letter C goes up, down, back up in pi. Yeah. D goes up, down, back up in pi over 2. Womp, womp. Yeah?
Yes.
Okay, moving on. Now we're going to start looking at a phase shift. Okay, this is going to be scooting to the left, scooting to the right. These are very, very hard for me to see because they're oscillating functions. And a phase shift to the right could look like something negatively phase shifted backwards. It all kind of goes together for me here. Okay, so horizontal translation is called a phase shift. It's not just a horizontal translation. We call it a phase shift because I'm moving the entire function and all of its oscillations and all of its continuity forever and ever shifted. Okay. What you should know is that cosine is just a phase shift of sine, right? Cosine is a move of the sine function in which direction?
Pi.
pi, how many? Yeah. So if I take the sine function, let's imagine, take my sine function that goes like this. Okay. Cosine takes this point right here and scoots it back to the y-axis. Whoop, whoop. So cosine is actually equal to sine of theta plus how many? Where does sine max out there? Sine of what equals 1? Pi over 2. Good. So cosine is actually sine of theta plus pi over 2. It's a phase shift of pi over 2. Yeah. Cool beans. Backwards, so plus, because insiders lie. Yeah. Okay, let's look at example 6. It says the figure shows a graph of trigonometric function g. Which of the following could be an expression of g of x? Okay, g of x. First, let's find the what, Truett? What do you want to find first?
What?
For 6.
The amplitude.
The amplitude? What did you say the amplitude is? I was thinking midline. Midline puts us at -1. They all have that, right? Amplitude. What you got for amplitude, Truett? 3. Amplitude is 3. Do they all have that 3?
They can't have a negative amplitude because it's always absolute value.
It could be reflected. Could be reflected.
But it's also not because it's shifted by pi.
What shifted?
Is it not? Did I get-
It all looks the same. Okay,
If it was reflected, it'd still be.
okay, so let's work through A. Let's pretend like our answer is A. Let's see what happens. So we take cosine of x, which is supposed to go through 1, right? 0, 1. And we shift that particular piece left, right. Does it shift left, right? No, not here. What if we amplify it by a factor of 3? Is that where this intersects? No. Even if I shift it down 1, still no. So no on A. Y'all following? Yeah, let's try B. Let's try to start it at 1 like it's supposed to. Okay? Amplify it by a factor of 3. Now I'm at 3, right? Reflect. Now I'm at -3. -1. That drops me down to -4. Potential here, right? Except then it's supposed to move. And this one would be cosine of x with not moved. Do you understand what I'm saying? So B is out. Let's try C. C says it's a sine curve. Where does sine start? 0. Okay, so we're going to go through the same process. Starts at 0, supposed to be amplified by a factor of 3. So +3, now it's just +3. Bump it down 1.
+2.
Okay, +2. Now shift it to the left, pi over 2. Quite possibly, right? And then it's supposed to go from this point, it would go up. Is that right? Does it?
I think it's just over, like, it could be C or D in my eyes.
I don't think that this one works. Let's try D. Let's try D. It's E, she says. Okay, I'm going to get a different color here. Okay, so for D, supposed to start at 0. Are y'all with me? Reflect it. So amplify it first. I go up to nothing. Reflect it. Still at 0. Shift it down 1. and then shift it right 3 pi over 2. There we are. I finally hit my function.
Yeah. Looked at it. I chose C before, and I went back and looked at it.
Say it again. If it was calculator active, you'd just plot them all? Yeah. That's fair. Well, that's what we just did, essentially. We don't love. Okay, moving on. All right, quickly, let's go to example 7. It's kind of the same question here.
But it's easier.
But it's easier?
Yeah.
Why? What's the midline?
Because we've got a
+1. They all say that. What's the amplitude?
2.
They all say that too. So now we've got to go to work, don't we? What's the period?
Pi.
Uh-huh. Period is pi.
Divided by 2.
So that means that my D is... Okay. Can I give you just let's get out of the weeds here? Would that be okay? Okay. So let's do this. Let's plug in 0 for x. What does that do for me?
It zeroes out the middle.
It puts me on the y-axis, right? If I plug in 0 for x, I am usually finding a y-intercept, yeah? Always. If I plug in 0 for x, I'm going to find me a y-intercept. Okay, so let's do this. I think that based on this information and it being a phase shift, I'm going to say that it's not cosine. Because cosine would start up at the top. And none of these cosine options are reflected. Can you see what I'm saying there? If it was cosine, there would have to be a negative in front of either one of these. Because this doesn't start at the top, it starts at the bottom. Which would mean cosine has been reflected. You with me so far? Okay, so here's what we're going to do. We're going to plug in 0 into both of these for x. Okay, so I'm going to start with the top one, letter C. 2 sine of 2 times 0 minus pi over 4 plus 1. So I'm plugging in 0 for x. Not everything cancels. I'm plugging in 0 for x. Okay, so I've got 2 sine of 2 times 0 minus pi over 4 is negative pi over 4 plus 1. Okay, I'm evaluating. 2 times sine of, this is 2 times negative pi over 4. What happens with the 2 and the 4? Now they're negative pi over 2 plus 1. Now, what is sine of negative pi over 2? That's going to be unit circle backwards. So negative 1. 2 by negative 1 plus 1.
2.
Negative 2 plus 1. Bingo. My y-intercept should be negative 1. You like that better?
Yeah.
Okay. Test the other one. This says 2 sine of 2 times 0 minus pi plus 1, right? So that would be 2 sine of negative 2 pi. Sine of negative 2 pi is 0 plus 1. No dice. That puts me at positive 1 on my y-axis.
Yeah, let's do that instead.
You like that better?
Yeah.
Okay. I thought so. So you can eliminate as far as you can, but really plug in 0. Find your y-intercept.
So I just saw the +1, so I knew that it was going to go through the origin, but it was going to be up 1, so I looked at where it was going to be at 1, and I knew it was right by pi over 4, so I looked at which one was minus pi over 4, and obviously if it was going through the origin, it wouldn't be a cosine function.
Okay. What you got, Grace? Negative 2 pi. Right, negative 2 pi is going to be, so we're starting we're going back this way. Sine of 2 pi would be your y value there. 0.
But then wasn't it sine? Oh,
Never mind. Grace got it. All right, last one. Last one for today. Example 8. You hate it? You can't hate it. You can't already hate it? No. Okay, so we've got numbers here. We've got F. Coordinates for F are 2, 16. G, 5, 11. J, 8, 6. K, 11, 11. Make a wish. P, 14, 16. Okay, so what do we know from those coordinates?
The midline 0.
Midline's not 0. Midline's 11. Somebody knock him out. Midline equals 11. So what is that, though? What value?
It's also shifted over to
Look at your function.
D.
D. Midline. D equals 11. And then what? Amplitude is 5. I'm liking that. What else?
it's shifted.
Wait, pause. Okay, she's good. All right.
It's shifted right to.
Shifted right to.
Because it's a sine function. So it has to go through the origin. So starting at 2. No, that might be wrong. Never mind. Don't listen to me. Don't listen.
Don't listen. Negate everything. No. Okay, let's talk about the period. How can we see the period from this particular function? We might want to measure from F to P. I like it. So from F to P, what do we have? 12. Okay, so our period is 12 units long. Yeah? So 12 is equal to 2 pi over b. I like it. Good job, Joseph. And then what? Solve for b. So I would multiply both sides by by b. So 12b is 2 pi. So what do you know about b? Pi over 6. Nice. Okay, we've got A and B and D. Now C. Where does it feel like? Let's get one more point on this graph. Let's go back to or maybe let's label this point right here. These are 3 apart, aren't they? 2 to 5, 5 to 8, 8 to 11. I feel like these are 3 apart. So what's your ordered pair for this guy right here? Okay. That's your origin. Y-intercepts at, if I go to 0, right? But this is my starting place. So it's shifted which way? Plus 1 because it went left 1. So what's your C? It's going to be on the inside. T plus 1. Yeah, so C is negative 1. But on the inside, what you would actually see, T plus 1. Yeah? And B, on the outside of that, is going to be pi over 6. And it moved up 11. And it's a sine curve. And our amplitude is, and this is called H of T. H of T. Any questions here, guys? All right.